Hi, hello students, good evening everyone. I hope all are doing well. Anyway, welcome back all of you to Infinity Learn JEE YouTube channel. This is Miss Surya, your chemistry faculty from Infinity Learn. If anyone is watching this particular live, just give me a hi to inform that if I am audible or not. Okay, I hope I am perfectly audible to everyone. Today we are going to discuss about the new topic, that is about the alkynes and the hydrocarbons part. The last sessions we have already discussed about the two types of saturated hydrocarbons, right? Starting from the alkenes, then we have already covered with the alkenes. Today we are going with the third part, that is the alkynes. What do you mean by alkynes? Again, this is also the next type of unsaturated hydrocarbons, right? So, alkanes are the unsaturated hydrocarbons that contain one triple bond. At least one triple bond is known as the alkynes. In general, these alkanes can be represented as CnH2n-2. As we already know, in the case of alkane, it will be CnH2n plus 2. And in the case of alkenes, it will be CnH2n. Similarly, here in the case of alkynes, it will be CnH2n-2. So that we can write down the members of the alkyne series like this. For example, if I am taking the first carbon, right? In general, if you are taking one carbon here, it will not be present. So I will take it as a 2 here. So it will be C2H4 minus 2, that will be H2, right? This will be our first member known as acetylene. Then what about the next member? 3 carbon compound. It will be C3H4, right? C3H4. This acetylene is known as ethyne because it contains 2 carbon compound. Here it will be propyne because of 3 carbons present. Then next one. Butane, right? So, as we are checking about the members of the alkane series, we can see that there will be a difference between CH2 molecules, right? CH2 molecules. So, we can call these series as the homologous series of alkynes. What we can call as, it is homologous series of alkynes. This is the basic part about the alkanes introduction. Now let us talk about the nomenclature of alkynes. How we can name according to IUPAC for the alkynes. As we already know, when we are studied about the alkynes and alkenes, right? In the case of alkanes and alkenes, the suffix will be ane or ene, right? Here in the case of alkynes, the suffix can be changed to YNE. YNE is the suffix for the alkynes nomenclature in the case of IUPAC. So let us start with the naming of first compound here. CH triple bond CH. How many carbons are present there? 2 carbons, right? So here the common name for this compound is known as acetylene. Again, this compound is containing 2 carbons. According to IUPAC, the name should be given as ethyne. 2 carbons stand for ethene. Then suffix should be YNE. So the compound name will be ethyne. Clear? The name for the next compound is CH3C triple bond CH. Again, here should be 3 carbons, right? The common name for this compound is acetylene. Instead of one hydrogen atom, the methyl group is substituted. So we can call this as methyl acetylene. This is the common name for this particular compound. Then what will be the IUPAC name for the second compound according to the number of carbon atoms? Yes, propane, right? Because 3 carbon atoms are present there. So this compound is known as propyne. Then what about the next one? The next compound is CH3CH2 C triple bond CH. Again 1, 2, 3 and 4 carbon atoms are present, right? 4 carbon atoms are present. If you are taking as the part of an acetylene molecule here, one of the hydrogen atom is replaced by ethyl molecule, right? So we can commonly name it as ethyl acetylene. Ethyl acetylene. Then what will be the IUPAC name for this compound? Four carbons, right? So it will be butane. The next one is the next compound. Here you can see that there is only a difference between the position of the triple bond, right? Position of the triple bond. So if I am naming like this, the common name will be become as dimethyl acetylene, right? In the case of CH triple bond CH, 2 hydrogen atoms are replaced by 2 methyl molecules. So it is known as dimethyl acetylene. Then what would be the IUPAC name for this compound? What we have to mention here, we need to mention the position of triple bond also here. That is the important thing for writing the IUPAC name for the alkanes here. So this is the 4 carbon compound, right? So the root name will be but. The position of the triple bond will be 2, right? So whenever you are naming the compound, you need to give the number like that. The triple bond will given very least number here. So here it will be 2. So I can write it as but2ine. Clear? The but stands for 4 carbon compound, 2 stands for the position of triple bond, ine stands for this is a triple bond compound. Is that clear? Now let's quickly talk about the next 3 compounds. Next one, it is the C3H7 C triple bond CH. Here you can see that the common name for the compound is known as N-propyl acetylene. Instead of acetylene, in the place of hydrogen, N-propyl group is replaced to form the C3H7 C triple bond CH to form N-propyl acetylene. What will be the IUPAC name of this compound? You can write this the same compound as like this. Can I write the same compound like this? Is that right? Is both the compounds the same or not? Same, right? So we can name these compound as, this is the first carbon, second, third, fourth and fifth, right? So this is the 5 carbon compound. The common name will be N-propyl acetylene and the IUPAC name will be pen1ine. Clear? Similarly, in the next compound, you can write it as isopropyl group, right? As we already discussing about the IUPAC nomenclature of alkanes and alkenes, we have studied that CH3 twice compound is known as iso compound, right? So here, the compound can be represented as, this is the iso part. So the common name will be become isopropyl acetylene. Isopropyl acetylene. Then what will be the IUPAC name for the compound? the same command I can be write like this, CH3, CH, CH3, C triple bond CH, which means 3-methyl but-1-ine will be the IUPAC name for this compound. You need to mention the position of branch also. 3-methyl but-1-ine will be the IUPAC name for this compound. Similarly, you can write down the IUPAC name for the last compound also. Just let me know the answer in the comments. For the tertiary butyl acetylene, what will be the IUPAC name? Or otherwise, take it as a homework to find out the IUPAC name for this particular compound. Now let me move to the next topic from the alkanes part, that is about the isomerism. What do you mean by isomers or isomerism? This particular topic, as we have already covered in the alkanes and alkenes part, right? Isomers are the compounds which have the same molecular formula but have different structures, right? Different structures, positions, or something else is known as the isomerism. Yes, 2,2-dimethyl propane, right? Propane or propyne? It should be propyne because it is a triple bonded compound, right? Clear? Then, what are the possibilities for isomers in the case of alkynes? Whenever we are discussing about the alkenes, we have discussed about the structural isomers and the optical isomers, right? Or geometrical isomers in the case of alkenes. But in the case of alkanes, there will be a strong triple bond, right? So there is no possibility of any geometrical isomers in the case of alkanes. We can talk about only the structural isomerism. Then, what do you mean by the structural isomers? What is the difference between the structural isomers? Any of the compounds, right? Any of the compounds which have the same molecular formula but have difference in their structures are known as structural isomers. So, for example, if I am taking any of the alkyne compound, right? Yes, you are correct, Devil. Okay. If you are taking any of the alkanes, right? You can give me an example. For example, if I am taking butane, right? Okay, what are the possibilities of the isomers in the case of butane? Butane means 4-carbon compound, right? Okay, this is the one possibility, right? What will be the name of this particular compound? What will be the name of this compound? I mean IUPAC name of this compound. First you need to check the number of carbon atoms, then give the position of triple bond here. 4-carbon compound, right? So it will be but. What will be the position of triple bond here? While giving the number of the bonds, you will be giving the least number to the triple bond. So it will become but-1-ine. Right, but-1-ine. So this will be the first formula for the butane. Is there any other possibility? Yes, Srinivas, you are also correct. It will be but-1-ine. Is there any other possibility for this particular butane compound? Yes, Mansi, you are also correct. Okay, I will draw another structure for this particular compound. You can give me the name. Okay, what is the name for this compound? Yes, both are correct. You can write it as but1-ine or 1-butyne. Both are correct. You need to mention the number for the triple bond. Yes, but2-ine or but2-ine, right? So this is the name for this particular compound. Okay, what is the difference are you observing here? What are the only difference observing between these two compounds? Yes, position of triple bonds, right? Yes, position of triple bonds changes here. As you can see over here, both the compounds are the same molecular formula of C4H6. The only difference in their position of triple bonds, right? So we can call these type of structural isomers as positional isomers, right? Positional isomers. These positional isomers are the type of structural isomers in which there is only the difference in the position of bonds. Got it? Now take a pen and paper with you. Write down the possible isomers for the next compound, that is pentyne. What are the different possible structural isomers for the compound pentyne? Then give me the IUPAC names of different compounds in the comments. Okay, are you getting the same isomers here? 3 types of isomers, right? Yes, what are the names? This will be pen1-ine, right? 5 carbon compound, triple bond in the first position. Then what about the next one? Again 5 carbon compound, right? Pent. But the position of triple bond will be the second position, right? So it will be pen2-ine. Then what about the last one? What is the IUPAC name for this particular compound? Hi Paranita. What is the name for this particular compound? You need to mention the position of carbon here. So it will be 3-methyl but1-ine, right? 3-methyl but1-ine will be the IUPAC name for the third compound here. So we can say that these 3 are the different isomers for the pentyne molecule, right? Now you need to give me the answer like that. Which are structural isomers and which are positional isomers? Which are chain isomers and positional isomers? In the case of structural isomers, we are going to discuss about two types of isomers. One is positional isomers, only the change in the position of triple bond. Then in the case of chain isomers, which means that it's a type of structural isomers in which have the same molecular formula but only difference in their chain. If you have any branches, we can call it as chain isomers. Clear? So here you can see three set of isomers here. Just mention which are the position isomers and which are the chain isomers. Yes, first and second are position isomers, right? Okay, these are the position isomers. Then what about the others? If I am taking the first compound and third compound, this is my first compound, this is the third compound. Is it a positional isomer or chain isomer? Hi Ajitesh Gupta. If I am considering first and third compound, is it a position isomer or chain isomer? Yes, it is a chain isomer, right? If you are observing here, in the case of first compound, it will be a straight chain compound, but in the case of third compound, it will be a branched chain compound, right? So these are the chain isomers. Similarly, you can say that compound 2 and 3 are also chain isomers. Is that clear, everyone? Okay, fine. Now let us talk about the preparation methods for hydrocarbons, particularly for the preparation method for the alkynes here. Ajdesh, this is the class for JEE 2026 percentile booster. Daily we are going live for the different classes for maths, physics and chemistry. Okay, let us see the preparation method of alkanes here. First method of preparation is from the calcium carbide. This is the industrial method of preparation of alkynes. As you can see over here, this is our compound, right? Calcium carbide, which will react with water to form acetylene, our simplest alkyne. Plus calcium hydroxide. Then in your NCERT textbook, it is given that how we can prepare calcium hydroxide and calcium carbide. As you can see over here, this is the method of preparation of quicklime and coke. So here, what do you mean by limestone? Limestone. I hope you have already studied in your small classes. It's about limestone, right? CaCO3. This is our limestone. This limestone on heating, it will produce calcium oxide plus oxygen, right? So this calcium oxide is known as quicklime. Calcium oxide is known as quicklime. These calcium oxide further react with coke, which means carbon, to form CaC2, our calcium carbide plus carbon monoxide. This is the method of preparation of calcium carbide, which is already mentioned in your NCERT textbook. Just go through it. Here you have to note that the preparation of acetylene is from the calcium carbide on hydrolysis, or the addition of water molecule to form acetylene or C2H2. Is that clear? So universe, are you asking about these products? Instead of carbon monoxide, it will be carbon dioxide, right? Yes, sorry, it's my mistake. This carbon dioxide, right? Yes. Calcium oxide plus carbon dioxide will be the product. Yes, you are correct. Okay, is the part clear? Can you move to the next method of preparation of alkynes? Okay, fine. Here is the next method of preparation of alkynes, as we already seen in the method or the chemical properties for the alkyl halides, right? Alkyl halides. So here, if you are taking vicinal dihalides, what do you mean by vicinal dihalides? Vicinal dihalides. If two halogen atoms are present in the same carbon atom, right? So these are known as the vicinal dihalides, which on treatment with alcoholic potassium hydroxide. Alcoholic potassium hydroxide, it will undergo dehydrohalogenation. One hydrogen and one halogen will eliminate to form the dehydrohalogenation to form the product alkynyl halide here. For example, if I am taking this compound, right, CH2Br, CH2Br, I am reacting it with the alcoholic potassium hydroxide. What I am observing here, this one hydrogen from the one carbon atom and one bromine from another carbon atom get releases as HBr, right? So it will form the compound like this, CH2 double bond CHBr. This compound is known as alkynyl halide. Clear? Alkynyl halide. Now after that, I am treating this particular alkynyl halide with sodamide. Sodamide means NaNH2. What I am observing here, similarly, the another bromine and another hydrogen as releases as minus HBr here to form a triple bonded compound, which means acetylene here or ethyne is the product here. Is that clear? The main point you have to keep in mind is that in the case of dehydrohalogenation of vicinal dihalides, the reagent which is used here, it is alcoholic KOH. After using alcoholic KOH, these vicinal dihalides will be converted into alkynyl halide. Then on treatment with NaNH2 or the sodamide, it will form the alkyne group. Clear? Fine. So far we discussed about the nomenclature as well as isomerism and preparation method for the alkanes. Now let me move to the next part of the alkanes, that is the physical properties. Let us see the physical properties of alkanes one by one. Okay. These are the major physical properties of alkenes. As we already know, the first three alkanes, right? Which are the first three alkanes by name? Ethyne, propyne and butane, right? These are the first three members of the alkane series. So we can call these three series are the gases in nature. These are gases in nature. Then what about the next one? Next higher alkanes. Next 8 alkanes are liquids and all others are solids in nature. This is the physical state of the alkanes. First 3 alkanes are gases in nature. Other 8 alkanes are liquid in nature, and last one, all the higher alkanes are solids in nature. Now let us talk about the weight of the alkanes. As we are comparing with the water, we can say that all the alkanes are lighter than water. All the alkanes are lighter than water. Then, if you are trying to dissolve any of the alkanes in water, okay, if you are trying to dissolve this in the water, what will happen in the, whether it is dissolving or not? It is insoluble, right? So here in the case of alkenes, just like alkenes and alkenes, all the hydrocarbons are insoluble in water. Then When you talk about particularly about the acetylene, we can say that pure acetylene has a pleasant odor. Then what about the physical properties like melting point, boiling point and density of the alkynes? Melting point, boiling point and density of the alkanes. As we already know in the case of alkanes and alkenes also, as the molecular mass increases, boiling point, melting point also increases. Similarly, in the case of alkanes also, the melting point, boiling point and density increases with increasing molar masses. Clear? Is the thing clear? So this is all about the physical properties of alkenes. Now let me move to the chemical properties of alkanes. Here we have to discuss these 4 types of reactions in the case of alkanes. First one is the addition reactions. We have to talk about the addition of hydrogen, halogens, hydrogen halide and water in the case of alkenes. The next one ozonolysis, as we already seen in the case of alkenes also. There is a small difference between alkenes ozonolysis and alkynes ozonolysis. Then the polymerization and the last one acidic character of alkynes. Let us see one by one. The first type of reaction is the addition reactions. If you are taking about the addition of hydrogen, right? If you are taking any of the alkanes, then we are adding hydrogen in presence of finely divided nickel, platinum or palladium as catalyst. What we are observing here, what we are getting? Okay, just think about that. If you are increasing the molar mass, what will happen to the boiling point? In the case of alkenes, alkenes and alkanes, whether it is increasing or decreasing. Okay. For example, if I am taking the first alkane, right, CH triple bond CH or our acetylene or ethyne, I am just adding H2 molecule in presence of nickel, platinum or palladium as the catalyst. What I will get? The first step, what I will get? Whether it is an alkene or alkane. I am getting an alkene right here. It will be ethyne. If I am continuing the same process by adding hydrogen in presence of nickel, palladium, platinum, I will get an alkyne compound, right? Alkane compound. It will be CH3CH3, our ethane molecule. Clear? If I am taking ethane molecule, I am adding hydrogen in presence of nickel, palladium or platinum as the catalyst here. I will first get an alkene compound, then further reaction it will combine to form an alkane compound, right? Yes, right. If I want to stop this particular reaction by this step, what I have to do here? Anyone? I need to stop this reaction by alkynes to alkenes only by adding hydrogen. We can just change the catalyst here, right? If I am taking Lin-class catalyst, as we already discussed in the case of alkenes, this is a Lin-class catalyst, palladium in presence of barium sulfate. This is known as a Lin-class catalyst. If I am adding hydrogen in presence of Lin-class catalyst, the product will be substituted to alkenes only, right? It will be substituted to alkenes only. For example, if I am taking any of the unsymmetrical alkynes, right? Unsymmetrical alkynes, I will particularly get a cis alkene here instead of this compound. If I am taking Lin class catalyst as the compound here, it will produce cis alkenes. Then instead of Lin class catalyst, if I am using sodium in liquid ammonia, I will get a trans alkene here. Okay, this is one of the method of preparation of alkenes as we already discussed in the case of alkanes part. Is that clear? Okay, fine. Now let us talk about the next addition reactions here. Addition of halogens. Instead of hydrogen, I am adding halogen here, right? Especially I am adding chlorine or bromine. Chlorine or bromine in the case of alkenes. For example, you can see here, this is our ethyne molecule, CH triple bond CH. I am adding Cl2 molecule in presence of a solvent here. It is taken as carbon tetrachloride, CCl4. What you are observing here? Two chlorine atoms are coming here like this. CHCl double bond CHCl. The name of this compound will be 1,2-dichloroethene. 1,2-dichloroethene. Right? Similarly, to this particular compound, I am again adding Cl2 in presence of CCl4. What I am observing here? Again, two more chlorine atoms are adding here. Right? So it will form Cl2 CHCHCl2. This is known as 1,1,2,2 tetrachloroethane. 1,1,2,2 tetrachloroethane. This particular compound is commonly known as bestron. Clear? Now in the case of halogenation or addition of halogen, I have already mentioned that instead of chlorine we can also add bromine, right? For example, if I am taking any of the alkane compound, then I am adding Br2 in presence of CCl4, right? Bromine in presence of carbon tetrachloride. What I am observing here, similarly instead of chlorine you will get a bromo compound right here. It will be 1,2-dibromoethene. Then finally it will be 1,1,2,2 tetrabromoethane. Then here you have to mention that this is a method of test for the unsaturation, that if you are taking bromine in CCl4 compound, right? Bromine in CCl4 compound. If you are taking any of the unsaturated compound, you are adding bromine in CCl4. Bromine has a reddish brown color, right? Reddish brown color. After forming the reaction, this color of the compound disappears, right? So, decolorization of bromine in CCl4. Decolorization of bromine in CCl4 is used as a test for unsaturation. Is that clear? For example, if you are taking any of the compound, you are just adding. In one test tube you are taking any of the compound, another test tube you are taking another compound. If you are adding bromine CCl4, in the first test tube the color disappears. It means that this compound contains a triple or double bond, which means it is an unsaturated hydrocarbon. Clear? Yes, fine. Now let us talk about the next type of addition reaction, that is the addition of hydrogen halides or halogen acids. Hydrogen halides or halogen acids. For example, if I am taking same molecule of ethyne, right? CH triple bond CH, I am adding HBr here. What I am observing here, one of the hydrogen atom is coming here and one of the bromine atom is coming here to form CH2 double bond CHBr. CH2 double bond CHBr. As you are observing here, you can say that this halogen atom is attached to a carbon which is a part of a double bond, right? Which is a part of a double bond. Such type of compound is known as vinyl. Vinyl compound here. Here it is bromide. So we can call this compound as vinyl bromide. Clear? Vinyl bromide. So if you are taking alkane By adding HBr or any other halogen acid, you will get a vinyl compound here. Again, to this particular compound, I am adding one more molecule of HBr. Then I am observing this hydrogen will go to this compound and this bromine will go to this compound as according to our Markovnikov rule. What do you mean by Markovnikov rule? Markovnikov rule. If you are having unsymmetrical alkenes, if you are adding any of the molecule, the negative part of the adding molecule or addendum will go to the carbon containing less number of hydrogen atoms, right? Here, this is our alkene, the negative, this will be the H plus and Br minus. The negative part of the adding molecule HBr, that is the Br minus, it will goes to the carbon that is containing less number of hydrogen atom. Here it will be go to the CHBr part to form CH3CHBr2. So it will finally form the compound known as geminal dihalide. Okay, what do you mean by geminal dihalide? The two halogen groups are attached to the same carbon atom, right? Same carbon atom is known as geminal dihalide. Here it is bromine is attached, so it is formed as ethylene bromide. This will be the name for this particular compound. So this is the chemical property or the addition reaction of alkynes with the halogen acids or hydrogen halides. I hope it is clear. Now let us talk about the next special type of addition, that is the addition of water molecule. Then one more thing you have to keep in mind that if you are taking hydrogen halides like this, the HI will have the maximum order than the HBr than the HCl according to the electronegativity order. Clear? Now let us talk about the addition reaction along with the water in the case of alkanes. Here we have already seen about the physical properties of alkanes. Alkanes are generally insoluble in water, right? Insoluble in water. So here, if you are taking any of the compound alkenes, if you are trying to dissolve it in the water, it will be insoluble. Instead of using any of the compound, we can say that these alkanes can be add water in the presence of mercuric sulfate, right? Mercuric sulfate, HgSO4. Then dilute sulfuric acid at 333 Kelvin. This is a special case. You can add water to alkanes in the presence of mercuric sulfate and H2SO4, sulfuric acid at 333 Kelvin. You will get carbonyl compounds, right? Carbonyl compounds, which means compounds that contain C double bond or group. So here if I am taking CH triple bond CH, same acetylene, right? This reagent can be represented as Hg2 plus, stands for HgSO4. Then H plus represents the sulfuric acid here at 333 Kelvin. Right? What we are observing here, I can write water as H and OH, right? So it will form right, CH2 double bond CHOH. This is the first compound formed after reacting water with the alkane compound. This compound is known as enol. There is a double bond as well as in hydroxy group, right? So it will be known as enol group here. Then here you have already seen about the tautomerism. As you can see over here, this bond will come here and this hydrogen will come towards here, so it will form clear? It will form a carbonyl compound here. Clear? So this is a special type of reaction in which alkanes are reacting with water in the presence of HgSO4 or mercury sulfate in presence of sulfuric acid at 333 Kelvin. First it will form an enol, then it will tautomerize to form corresponding carbonyl compound. Is that clear? Now let us talk about the next type of reaction, that is the ozonolysis of the alkanes. As we already seen in the case of alkenes, ozonolysis is a reaction with ozone, right? Is a reaction with ozone. Okay, this is our compound ethyne, right? So I am adding ozone molecule in presence of zinc in water, right? In presence of zinc in water. This is our ozonolysis condition. So if I am adding ozone molecule in the presence of CH triple bond CH, it will form an ozonide, right? Okay, this is our ozonide molecule. As you can see over here, instead of alkene, here the CC bond become intact, right? There will be a CC bond. Then ozone molecule is combining here to form an ozonide molecule. Then what you are observing here? Here this bond will break like this, and this bond cleave from here. Then it will form right. This is the final product of ozonolysis of alkane or the acetylene here. This particular compound is known as glyoxal, or it is also known as dicarbonyl compound. Clear? Okay, what you are feeling here, whether it is reductive or oxidative. Here this bond is cleaving, right? So we can call it as reductive. Instead of here, if I am using H2O2, right? H2O2, this is an oxidizing agent. Similarly, this H2O2 I can be written as OH, right? OH. Then what you are observing here, if I am adding H2O2 to this glyoxal molecule, this bond breaks, then one of the OH group come here and another OH will come here to form the product like this, HCOOH plus HCOOH, right? Two formic acids. Clear? So here we can call this as the oxidative ozonolysis, right? Further oxidation is happening here, so this is known as the oxidative ozonolysis here, right? Yes. If you are taking zinc and water here, we can call this as a reductive ozonolysis. Simply the bond breaks and ozonide is forming. Here it will form the glyoxal molecule. And further, if you are reacting with the H2O2 molecule, mild oxidizing agent here, it will oxidize to form the corresponding carboxylic acid. So this is known as the oxidative ozonolysis. Is that clear? Next, if you are taking propine on ozonolysis, what will happen to the product? What will be the product? First, you have to write down the ozonide. then break the bond, you will get the glyoxyl compound here, right? Okay, this will be the final product for the osmolysis of propyne molecule, methyl glyoxyl. Is that clear? Similarly, you can write down the product for the other higher alkynes also by using this method. Instead of using H2O2 here, similarly you can get the corresponding carboxylic acid here.
So we can also define A minus B, right? Set up all X without E.
1 mole of acetic acid plus 1 mole of formic acid you will get as the product here. I hope it is clear for everyone. Now let us talk about the next chemical properties of alkenes, that is the polymerization. As we already know, polymerization means whenever many of the monomer units that combine together to form a large chain compound is known as polymers, right? Here in the case of alkane, there will be two types of polymerization happens. First one, it is linear polymerization. For example, if I am taking CH triple bond CH, that is our ethylene molecule, N molecules, if they undergo polymerization, it will form a polymer like this, polyacetylene. This is the method of linear polymerization in the case of alkanes. Now let us talk about the very important method, that is the cyclic polymerization of alkynes. Cyclic polymerization of alkenes. For example, if I am taking 3 molecules of acetylene molecule, 3 molecules of acetylene molecule passing through red hot iron tube at 873 Kelvin, it will undergo cyclic polymerization to form our benzene molecule. Clear? 3 CH triple bond CH molecule, it will react with red hot. It will pass through the red hot iron tube at 873 Kelvin. Temperature is very important here. 873 Kelvin, it will form the benzene molecule. For example, if I am taking CH triple bond CH like this. What you are observing here, one of the bond will come here and then will come here, then it will come here like that. Then it will forms CH single bond CH double bond CH single bond CH double bond CH single bond. Right, this will be our benzene molecule. Is that clear? So cyclic polymerization of alkane is very, very important. This is one of the method of preparation of aromatic hydrocarbons, which we are going to discuss in the next class. Method of preparation of benzene or the aromatic hydrocarbons. So this is very, very important. This condition is very, very important. Red hot iron tube at 873 Kelvin. Is that clear? Can we move to the last part? Now let us talk about the last chemical properties of alkenes, that is about the acidic character of alkynes, right? Acidic character of alkenes. As we already know, depending upon the position of triple bond, we can call these alkanes are internal alkanes and terminal alkanes. If you are observing any of the alkanes as terminal, right, which means triple bond should be at the first position, these are known as the terminal alkanes. These terminal alkynes and acetylene are very weak acids, Then we can represent the acidity order of alkenes depending upon their hybridization or the percentage S character, right? If you are taking any of the alkane molecule, alkene or alkane molecule, depending upon the hybridization, depending upon the percentage S character, we can call this as the acidity order. For example, if I am taking ethyne molecule, right? What will be the hybridization there? In the case of ethyne molecule, sp hybridization, right? sp hybridized carbon, which means 50% S character is present, right? 50% S character is present. So as we are observing about the S character, you can say that this will increase the electronegativity of the carbons, right? Electronegativity of the carbons, so that it can easily remove the terminal hydrogens. That is the characteristic of the acidic property, right? So here, if you are taking ethyne molecule, because of the presence of 50% S character, it will act as a strong acid as compared to ethene. Here it is sp2 hybridization, right? So it will be 33.3%. 33.3% S character. Then in the case of alkane molecule, it will be sp3, which means 25%, right? 25% S character. As the percentage S character increases, the acidic property of alkynes also increases. Clear? Is the point clear? Yes, Srinivas, you are correct. Now, as you can see over here, there is another order of alkanes, right? Another order of alkanes. What you are observing here, how we can predict the order of these particular alkanes? Okay, CH triple bond CH, right? This is our ethyne molecule. Then it is propyne, then butane, right? So as you can see over here, due to the presence of plus I group, right, methyl group or electron donating group, the acidic character of alkynes decreases here, right? So plus I effect is inversely proportional to the acidity. Yes, I hope it is clear. Now let us practice some questions based on the topics we have covered in the today's class. Here is the first question. Just give me the answer fast in the comments. What will be the product of ozonolysis of acetylene? CH triple bond CH. As we already seen, right? Yes, glyoxal, which means option 2 will be the correct answer. Yes, correct. Now here is the next question. The product Q and R in the following reactions respectively are. This is the addition of hydrogen in the presence of lint-class catalyst for the propyne molecule. It will form the P product, which on ozonolysis give the product as Q and R. What will be the answer? Okay, this will be our product, right? CH3CHO plus SCHO. CH3CHO is known as ethanol and SCHO is known as methanol. So option 3 will be the correct answer. Ethanol and methanol. Clear? Yes, here is the next question. The homologue of ethyne is, very basic part of the alkane. Ethyne means C2H2. What is the homologue of ethyne? Just add one molecule of CH2. You will get the next product as C3H4, right? C3H4, which means option 4 will be the correct answer. Here is the next question. Predict the correct intermediate and product in the following reaction. addition of water is here. If you are taking propyl molecule, if you are adding addition of water, first you will get an enol molecule, then it will undergo tautomerization to form corresponding carbonyl compound or ketone. What will be the answer here? So this will be the answer for this particular question, which means option 3 will be the correct answer. This is the last question. What is the decreasing order of acidic character among the ethene, ethyne and ethane? Depending on the percentages character, you can give the answer as option 2. That is the order here. So this is the last question. You can take it as the homework. Which of the following reactions will yield 2,2-dibromopropane? Just let me know the answer in the next session. So I hope it was clear for everyone. This is all from my side for today. Today we have completely discussed about the alkenes. We have seen about the basic part of the alkenes, IUPAC nomenclature, isomerism. Then we have seen about the physical properties as well as chemical properties. So here I am going to wind up. Before that, there is a reminder about the AATS. Finally, our JEE Main exams are over. So here Infinity Learn is providing you the AITS, All India Test Series for the JEE Advanced 2025. So you can enroll fast for this series. Then there is another opportunity for you to predict the college predictor. If you have your JEE Main exams here, if you are providing these JEE Main exam score in this list, you can get a list of colleges like IITs, NITs, IITs and government and private colleges according to your score. So link will be provided in the description. You can check your college. The last one, it's about the private exam series. If you are not getting any good rank in the JEE Main exams, no need to worry. There is another opportunities like these exams. So Infinity Learn is providing you an opportunity to attend these exams here. So enroll fast. You will get a 70% off by using this best 70 off code. So anyway, all the best for your exams. Thank you so much all of you. I will be coming back with the next class with the aromatic hydrocarbons with their isomerism and their IUPAC nomenclature. Till then, bye bye all of you. Thank you so much.
अगली बार